Hey students, before you get this video started, make sure your math notebook is open in front of you. You are going to take these notes on the right-hand side of your notebook, and then when you get to those Edpuzzle questions, if there's any work you need to do, show that on the left-hand side. All right, so our notes for today are going to be titled 1.4 Prime Factorization. And you'll be watching this video on September 11th, 2020. All right, our learning target for today is I can write the prime factorization of a number. So you're probably wondering what prime factorization even is. Before we get to the definition of that, there's a few other vocab words that I want to define for you that are going to help us. The first one is factor. A factor is a number, this sign means number, that divides evenly into another number. So for example, let's say I have the number 10, and I want to list the factors of 10. So that means I want to list all the numbers that divide evenly into 10. Well, 1 divides evenly into 10. So does 2, 5, and 10. All of these divide evenly into 10, which make them factors of 10. Our next word is factor pair. A factor pair is two numbers that multiply to get a specific number. So when we talked about factors, those are just single numbers that divide evenly into another number. A factor pair is two numbers that multiply together to give us this number. So let's use 10 as our example again. One factor pair of 10 is 1 and 10, because 1 times 10 equals 10. Because these multiply together to give us 10, they are a factor pair of 10. There's another factor pair for 10, and that would be 2 and 5, because 2 times 5 gives us 10. Again, they multiply together to give us 10, so they are a factor pair of 10. All right, now that we know what factors and factor pairs are, we are going to move into prime factorization. What is prime factorization? Prime factorization is writing a number as the product, and remember, product means multiplication, as the product of its prime factors. So I know that sounds a little confusing. We're going to go over an example to help it make a little more sense. But before we do, I want to remind you what a prime number is, right? In order to understand this definition, we need to know what a prime number is. A prime number is a number that is only divisible by 1 and itself. The exception to this is the number 1. 1 is not a prime number, but 2 is a prime number because the only things that go into 2 are 1 and 2. 3 is a prime number because the only things that go into 3 are 1 and 3 itself. I'm going to list a couple more prime numbers for you because these will become helpful later. 5 is also prime, so is 7, 11, 13, and it keeps going on forever and ever. All right, so let's do an example of what prime factorization is to help the definition make a little bit more sense to us. Okay, so in order to find the prime factorization of a number, we make something called a factor tree. So let's say we wanted to find the prime factorization of 48. Well, in order to break this down into its prime factors, I am going to find factor pairs. So I ask myself, okay, what are two numbers that multiply together to give me 48? Well, I know that 2 times 24 gives me 48. Well, 2 is a prime number, and we're looking for all the prime factors of this number of 48. So I'm going to circle this 2, this prime number, and this branch is now ended. We are not going to continue this branch anymore. But 24, that's not prime. I can think of many things that go into 24. So we're going to split this one up again. I ask myself, what multiplies together to give me 24? Well, I know that 2 times 12 makes 24. 2 is prime, so I'm going to circle it, and I'm going to end that branch. 12 is not prime, though. There are multiple things that go into 12, so I'm going to split this one again. I'm looking for two things that multiply together to give me 12. I know 2 times 6 is 12. 2 is prime, so I'm going to end that branch. And now I have this 6 over here. I know 6 is not a prime number. There are numbers that go into 6 besides 1 and 6. So I'm going to split this up again. I ask myself, what multiplies together to give me 6? Well, I know 2 times 3 gives me 6, and both of these numbers are prime. Now that every branch is ended in a circle, that means I'm ready to actually write the prime factorization of a number. So earlier I said the prime factorization of a number is when you write a number as the product of its prime factors. So that means you write it as all of its prime factors multiplied together. So that's what I'm going to do here. I'm going to take all of these prime factors and multiply them together. I'm also going to make sure I list them in ascending order. It means going from smallest to biggest, least to greatest. So I've got 2 times 2 times 2 times 2 times 3. So this is the prime factorization of this number. We wrote 48 as a product of all of its prime factors. One extra step we could take is to simplify this part of our expression. Remember in 1.2, we learned that when you repeatedly multiply something, that's the same as using an exponent. I could rewrite this with an exponent if I wanted to make it a little neater. So I have 4 2's here, so that would be 2 to the 4th power times 3. So this is our prime factorization. If I were to multiply these all together, I would get 48. And let's just remind ourselves this thing is called a factor tree. All right, let's do another example. We're going to take the number 20, So I'm trying to split 20 up so that I can find all of its prime factors. So I ask myself, okay, what multiplies together to give me 20? Well, I know that 2 times 10 gives me 20. 2 is prime, so I circled it and I ended that branch. Your factor tree could look different than this. You could have done 4 and 5 instead. There are many different factor trees for every number, but ultimately your prime factorization should be the same. All right, 10 is not prime, so I ask myself, what multiplies together to give me 10? Well, I know 2 times 5 gives me 10. Both of these are prime. So I found all my prime factors. Now I have to actually write the prime factorization. I have to write the prime factors multiplied together. So I have 2 times 5. Because I have multiple of the same number, I can write that with an exponent. That would be 2 squared times 5. So that's our prime factorization. These are prime factors multiplied together that will give us 20. All right, we're going to do one more example, 88. So I start by asking myself what multiplies together to give me 88? Well, I know that 2 times 44 gives me 88, and 2 is prime, so I can end that branch. We also could have used 8 and 11 instead. Again, there are multiple factor trees for every number, but your result should be the same. All right, 44 is not prime, so I ask myself what multiplies together to give me 44? Well, 2 times 22 gives me 44, and 2 is prime, so I circle it and end that branch. 22 is not prime, so I ask myself what multiplies together to give me 22? Well, I know 2 times 11 gives me 22. 2 is prime, so we circle it and end that branch. And 11 is also prime. Nothing goes into 11 besides 1 and itself. Now that I have all my prime factors, I have to write them multiplied together. I've got 2 times 2 times 2 times 11. And if we want to make it a little neater, we can write this using an exponent. We have 3 2's multiplied together, so that is 2 to the third power, or 2 cubed, times 11. All right, so just a really quick recap. A prime factorization is when we take a number and we write it as the product, right? Product means multiplication. We write it as the product of its prime factors, and we do that by using a factor tree. So we create our factor tree, we write all of the prime factors multiplied together, and then we simplify it if possible. If I were to multiply these all together, I should get 88 as a result.